Hello everybody, this is the part 3rd of the chapter 1 matter in our surroundings from class 9. In this video we will see the can matter change its state. This is a topic. Under this we will see the various subtopics. So let's start. Can matter change its state? As we know that matter can change its state. We know that water this in the liquid state. As we know that when we keep in this in the refrigerator, it gets converted into the ice cube. This is a solid form. When we heat it, it will get converted into the vapor form. This is the gaseous form. So we know that can matter change its states very clearly. Now the point is that what happens inside the matter during the change of state and what happens to the particles of matter during the change of state. When we will search the answer of how does the change of state take place, within that we will understand these two questions answers in the same thing in the searching of this third questions. So now come to the how does the change of state take place. Change of state take place by two methods, change in temperature and change in pressure. So now come first we will see the change in temperature. This is the experimental setup here. Here ice cubes in the beaker is kept under the constant low flame, and here one thermometer is put and it is continuously stirred. So the first question arises, when we provide the heat, what happens? The temperature of the system increases. First. Second, what happens? We know that all particles in the solids are closely packed and in their own position they vibrate. So they have definitely some kinetic energy. Okay, so their kinetic energy increases because of that reason. What reason? Temperature. When temperature increases, kinetic energy increases. When kinetic energy increases, the particles in their position will vibrate with the greater. Earlier it was spread, is vibrating in this way. Now it will vibrate like this. So in this way they will overcome the force of attraction. Particles will overcome the force of attraction and they will leave their fixed position and starts to moving, and they will move freely. And in this way, when the whose particles move freely, as we know that liquids particles move freely as well as gas also, but here when they are leaving their fixed position, next step they will go to the liquid. So solid gets directly here gets converted into liquid, and this process is called fusion. The process of conversion of solid into liquid is called fusion. So this is the change in temperature in case of solid gets converted into the liquid. Now we will see the next slide. The minimum temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. When we provide heat at constant temperature, it will start to melt. When we reach a particular temperature, this solid ice cube will start to melt into liquid. We know that, as we know that water starts to melt at 0 degrees Celsius or in the Kelvin 273 Kelvin. Okay, and this melting point also shows the strength of the force of attraction between the particles of the solid, because melting points occur for the solid, because solid starts melting to the liquid at the atmospheric pressure. So now further we will see that when we start providing further heat in this case, after starting not all ice cubes will melt at a time. It will take some heat energy. In this process we see that here the temperature will not increase, it will remain constant. So where does further heat goes inside the system? It is considered that it remains in the contents of the beaker. So that's why this is called hidden energy or latent form. Latent, the another meaning of latent is hidden. So what happens? This heat energy is called latent heat of fusion. Simple, because during the conversion of solid to liquid, this heat we provide. So during solid to liquid, we provide heat, and this there is no increase in the melting point, that remain constant. So that's why it is called latent heat of fusion. The definition is here: the amount of heat energy that is required to change 1 kg of a solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. The most important point is this melting point. Melting point will At the melting point at atmospheric pressure, 1 kg of solid gets converted into liquid by the providing of this latent heat of fusion. So latent heat of fusion is the what? It is the heat energy. It is the amount of heat energy. Okay. So now we will see further what happens when we increase the temperature. Suppose all the ice cubes has become melted into the water, then we further increase the temperature of the system, then what happens? As we know that in our day-to-day life, when we provide the further heat energy here, at certain temperature when it will reach, we know that in case of water at 100 degrees Celsius or in Kelvin condition 373 Kelvin, it will start to boil. But it is a bulk phenomenon because whole system will start to boil. Not only that upper surface will boil, after that lower, not. Whole system will start to boil. As we know that we have boiled tea or water simply. We have seen that in our home. That on heating water, what happens first? But with the particle will move faster. In this way, they will become free from the force of attraction, and they will move randomly at a certain time. It will the particles will starts to move randomly, and who moves randomly? The particles of the gases. So that means water gets converted into the vapor, that is it is the gas form, and the process of conversion of liquid into its vapor form is called vaporization. So this is the change in temperature. So what happens in the change in temperature? Particles starts to move faster, and particles will lose their or will overcome their force of attraction. They will start to move freely. Then they first gets converted into the solid, first converted into the liquid, then further heating process at a certain temperature, they will start to get converted into the vapor form. So because of the change in temperature, we will see in the next slide what happens. Some solids does not directly they does not gets the intermediate between the solid and gas. They directly converted into solid into gas. We will see in the next, and what is this process is called, we will see in the next slide. So on heating this water or liquid at a certain minimum temperature at atmospheric pressure, that starts to boil. So that temperature is called boiling point. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. Latent heat of vaporization. The same case in the case of latent heat of fusion, we have seen the further heating. What happens? Temperature will not increase; it will remain constant, but the hidden heat inside the system will increase, and that is called latent heat. When they converts into the solid and solid to liquid, that is called latent. The process is called fusion. So that's why this heat was called latent heat of fusion. But here we see that the liquid gets converted into vapor. That's why here we use the term latent heat of vaporization. And again, the definition is here: the amount of heat energy that is required to change 1 kg of a liquid into a gas at atmospheric pressure at its boiling point. In the latent heat of fusion, we told melting point. Now, in the case of latent heat of vaporization, we will have to mention boiling point. Okay, and this again, latent heat of vaporization is what? Amount of energy required to convert liquid into gas at boiling point. That is the most important point. So this is up to change in temperature. Now we will see change in pressure. What happens when change in pressure takes place? In the previous video, I have told you when we increase the temperature, particles come to the closer. When we increase the pressure, in case of gas, the particles will come closer, more closer, and then they will become more closer. Then suppose it is in a gaseous form, they are just scattered, widely spread it, so that will be in the liquid. They are closely packed, so it will be gas. Sorry, solid. When they are closely packed, then this shows that it is the particles of the solid. By changing in the pressure, we can also change the state of matter. Applying pressure and reducing temperature, we can liquefy gases. Gases can be liquefied. We know that CNG, LPG, all these are gases in the liquefied form. They are compressed inside the cylinder. One more example is here: solid carbon dioxide. It is stored under high pressure. Solid CO2 gets converted directly into the gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This solid CO2 is what? This is the dry ice. It is the other name of the dry ice. This is actually the solid carbon dioxide. As we know that the carbon dioxide exists in the gaseous form, but when we compress it like this process, by the compression process at reducing the temperature as well as pressure, here we are applying the pressure, external pressure we are applying, then uh, molecules will come closer and they will get converted into the liquid, and when we applying more forces, then they gets converted into the solid. So these are all about the change in pressure. So what happens? Change in pressure, particles come closer. If it comes just closer, widely separated, then it is liquid. When they are closely packed, particles comes together on compressing the pressure or applying the pressure on the gaseous particle, then they becomes into the solid. So that's all about the change, the how this change of state of matter take place. This is schematic representation of the conversion of states of matter, 3 states of matter. Here is liquid. When we solidify it, then molecules will come closer, more closer, then it will become solid. When we fuse it, fusion process, I have already told you the process of conversion of solid into liquid, it is called fusion. When we further heat it, it will boil, then it gets converted into a vapor form, and it's called vaporization. Vaporization, when we starts to condense it, when the molecules will come closer, then it will becomes condensation process. What? Liquids, they convert into liquid. When I will show you in the next slide what happens. Sometimes solid directly gets converted into gases, no intermediate liquid. That process is called sublimation, and directly gas is converted into the solid, that is called deposition process. This simple definition I have written here, just show it. Sublimation, a change of state directly from solid to gas without changing into liquid state is called sublimation. Solid will directly convert it into the gaseous form. In the camphor, when we burn camphor, we see that directly converted into the gas from solid to gas. No liquid we see in this case. Camphor. Dry ice, I already told you, solid CO2. Dry ice, that is the ice form when it is directly converted into the gaseous form. No liquid intermediate we will see here. Or same case in the ammonium chloride. One experimental setup in the given in the book that they will heat the ammonium chloride in the china dish, and they just inverted conditions of the funnel they keep, and heat is providing here. Then they will vapor will go here up, and after cooling they will crystals will be formed here. So it shows that no liquid here is we observe here. Directly they go in the vapor form. On cooling they will settle on the inverted funnel. So this is the sublimation. Deposition. Deposition is just the inverse process of the sublimation. Here the gas is here the gas is directly converted to solid without changing into liquid. That is called deposition. That is simple process. Now one more thing I have in my slide, which has more energy. This is the most important thing. Yeah, which has more energy. Water or ice at 0 degree Celsius. 0 degree Celsius is what? Melting point. Okay, and water or water vapor, which has more energy at 100 degrees Celsius. That means boiling point. We know that the amount of heat energy that is required to convert solid into liquid at melting point at the atmospheric pressure is called latent heat of fusion. Latent heat of fusion. In the same way, the amount of heat energy required to convert water into water vapor at boiling point at atmospheric pressure is called latent heat of vaporization. So, latent means what? Hidden heat. In this case, we know that at melting point, it is reach starts to melt. First case I am telling here, melting point it starts. Further, we provide the heat. So this heat is content is increasing in the system. After that, the solid will convert it into the liquid. So it shows that water will have more energy because of the latent heat of fusion. Water will have more energy at 0 degree Celsius. 0 degree Celsius is the most important point to mention here. That's why. And water or vapor at 0 degree Celsius. Again, here the same reason, not same reason, latent, some little variation, latent heat of vaporization is the reason. Because at boiling point, the heat content of the systems increases. Temperature is not increasing, but heat content is increasing during the vapor formation. So that's why this vapor has more energy as compared to the water. Vapor energy has more energy. So that's all about this video. In the next video, I will come with the evaporation process and the factors affecting the evaporation process. So thank you for watching this video.